Hi everyone, this is Farah here. This is your video for, first video for chapter 5. Now this is not 5.1 yet, this is an introduction to 5.1. So just want to go over some of the stuff that you learned in Algebra 1, but probably need a little refresher on. So the first thing that we're doing, well, everything that we're doing in 5.1 is simplifying square roots. I think this is already on your notes, but I printed an earlier vision. Oh, square roots, simplifying square roots. I'm not off to a very good start here. So we use what I like to call the jailbreak method, just because it works. Not that I'm encouraging anybody to do a jailbreak. Here's our steps. Step 1 is we're going to make a factor tree. So we all remember how to do that. That's not too hard. And then we're going to circle for a square root where our index is 2. We're going to circle groups of 2 to break out of jail. Only one number or variable from each pair survived the breakout. These notes will make more sense as we do some examples. Any factor without a partner, so anybody that doesn't have a group of 2 stays in jail, and any numbers inside and outside of the jail, you multiply. Okay, so the jail is the square root. So in order to simplify this, we have to break out or take out anything inside the square root that is a perfect square. And remember, our perfect squares are like square root of 4 is 2, square root of 16 is 4, square root of 9 is 3. So those are our perfect squares. So if there's any perfect squares inside this radical or inside this jail, we want to break those out. So the way we find them is we start by doing a factor tree. Doesn't matter how you start your factor tree, the bottom of the tree will be the same. So I'm going to start this as 50 is the same as 2 times 25, and 25 is the same as 5 times 5. So these are all prime numbers. So that is as far as my factor tree can go. So the square root of 50 can be written as 2 times 5 times 5, okay? So this is just a rewrite. These two are identical, just written in a different form. But when it's in this different form, I can find doubles or partners. So if you have doubles or partners like this, 2 5s, I'm going to circle those. So that's our step 2 up here, circle groups of 2 to break out. So these are the numbers in jail here that are going to be able to break out. So you need a group of 2 to attempt a breakout. When you break out though, only one member from this group of 2 survives. So I want to tell myself, all right, one of these 5s is going to break out. You'll notice this 2 never had a chance to break out because it didn't have a partner. So any factor without a partner stays in jail. So now who breaks out? One of these 5s, so they are outside the jail. Who is stuck in jail? This 2. Never had a partner, so could never break out. So this is my simplified radical. 5 outside the jail, 2 inside the jail. Okay? So step 1, do a factor tree. Get all your prime numbers listed. Then look for your doubles. Circle them, circle them, circle them. Some of these factor trees are going to get long. You're going to want to circle your doubles. I think this is a helpful strategy. Draw that arrow indicating one of these 5s is going to get out. So the 5 will be outside the radical. The 2, not circled, is left inside the radical or inside the jail. So only numbers or variables that are circled can break out. Okay, go ahead and pause the video. Try this one. I'll tell you, you should get for your answer 2 times the square root of 15. Okay, I'm going to do another example for you. You'll see mine quickly gets a little bit more complicated, but the same idea holds, because now we have, excuse me, now we have variables in there. Okay, so I have a 45, an x to the third, and a y to the third. So I'm going to do a tree on the 45. 45 is the same as 5 times 9. 9 is the same as 3 times 3. So I'm going to rewrite this radical. And instead of the 45, I'm going to write 5 times 3 times 3. Does not matter what order you write it in. Okay, and then the x to the third, I'm going to write as 3 x's. Because remember, I'm trying to find doubles. I can easily find doubles when I write them out this way. Y to the third, I'm going to write as y times y times y. Now, circle your doubles. So I have 2 3's. I'm going to circle those. I have 2 x's. I'm going to circle those. I have 2 y's. I'm going to circle those. So you can see this 5, this x, and this y are not circled. They're going to be left in jail, stuck in the radical. What's going to break out here? One of these 3's, one of these x's, one of these y's. So you can see if you do all these strategies, this ends up being really simple. What's on the outside? 3 times x times y. What's left on the inside? Anything that's not circled. 5 times x times y. There we go. Here is one for you to try. And I will tell you for this one, you should get 3A. You know what? I'm actually going to do this one because this, no, I'll let you try it. 3AB squared on the outside. And what would be left on the inside is 2AB. Okay, let's look at example 3. So in example 3, I have 2 square roots or radicals multiplied together. You have a couple options on this one. You can go ahead and multiply them first, or you can simplify them separately and then multiply your answer. I kind of like the simplify separately, because when I multiply first, I get a really big tree that I have to make. So I'm just going to tree this. This is 5 times 3. And then a 3, of course, is just 1 times 3. So you can see 15 can be written as 5 times 3. Square root of 3 can be written as 1 times 3. Well, that's just square root of 3. So there really isn't a tree for the square root of 3 because 3 is a prime number. Now I'm going to multiply them. I'm just going to put all of these numbers inside the same radical or in the same jail. When you're multiplying square roots, you can multiply them and put them all together in the same jail or radical. When I put them together, I'm going to put them in order. So I'm going to put the 2 3's first and then the 5. Helps to put them in order from smallest to biggest. Now, if you look at this, oh, there's some doubles. So the 3 is going to break out. The 5 is going to be left. So what I'm going to have is 3 on the outside, the 3 busted out of jail, square root of 5 on the inside. So now this is simplified. So let me show you quickly if I had multiplied first. If I had multiplied first, 15 times 3 is the square root of 45. And then I would have done a tree on that. Oh, if you look up here, we just did a tree on that, but I'll redo it. So this is 5 times 9 and 3 times 3. So this is the same as 3 times 3 times 5, the bottom of my tree. And then if I do a jailbreak on this, there's my doubles. 3 breaks out. 5 is stuck. Notice I get the same answer. Just two different options here, okay? So this is option 1, this is option 2. This is one for you to try, and the answer for this one is 2 times the square root of 10. So try that one on your own. A couple more. Example 4. Same idea. You'll notice I just have a number sitting outside jail here. So when I do the jailbreak on this, whatever busts out will get multiplied by the 5. I'll show you how that works. So 54. Remember, if you can't think of what goes into 54, just grab your calculator and try it. Think, okay, 54, I'm not sure what goes into 54. So do 54 divided by 2. Oops, I did times. Do 54 divided by 2. 27. Okay, so let's start our tree that way. 2 times 27. If you don't know what 27 goes into 27 evenly, try 2. Nope, that doesn't work. How about 27 divided by 3? Oh, 9. So 27 is the same as 3 times 9, and 9 is the same as 3 times 3. So this is the bottom of my tree. So this can be rewritten as, keep the 5 outside the jail. 54 can be written as 2 times 3 times 3 times 3. So 2 times 3 times 3 times 3. Okay, where's my doubles? There's 2 3s. So a 3 is going to break out. Who's stuck in there? A 2 and a 3. So outside the jail, this 5 is still sitting there. I like to say this 5 is the getaway car. 5 is sitting outside the jail, still there. 3 busts out. They are also outside the jail. Who's left in jail? 2 times 3. So one of our steps said multiply all numbers outside the jail and all numbers inside the jail. So who's outside the jail? 3 times 5, 15. What's inside the jail? 2 times 3, 6. Make sure you write that multiplication or parentheses. Otherwise, you might think that's a 53. And you might think that's a 23. So use the dot or use parentheses. Okay, so same thing, tree what is ever in the jail. If there's already something waiting outside, a getaway car, whoever busts out gets multiplied by whatever was already outside the jail. All right, let's look at this one. So I see, I already have a 3 outside the jail here, and I have a 5, and then I have a square root of 18. Now 5 is a prime number, so I can't really simplify this any further because 5 would just tree into 1 times 5. So I'm not gonna do that tree, but 18 I know I can do a tree on because right away I think, oh, 18, that's 2 times 9, and 9 is 3 times 3. So now I'm going to rewrite all of this. Don't skip steps, rewrite all of this. So I have 3 square root of 5 times square root of 18. I decided to write as 2 times 3 times 3. 2 times 3 times 3. Okay, doubles. Break out the 3. So working down here, I have 3 square root of 5 times 3 busted out. 2 is stuck inside the jail. Okay, now I need to do this multiplication. So numbers outside the jail get multiplied. So that's 3 times 3 is 9. Numbers inside the jail get multiplied. They're still in jail though. Don't let them out. 5 times 2 is 10. Now I do need to check and make sure this cannot be simplified any further. But if I do a tree on here, I just get 2 times 5. And then I know, okay, well, there's no doubles, so that can't be simplified any further. And if you think about it, at this step, when I multiplied, I could have written outside the jail is 3 times 3. Inside the jail is 2 times 5. That actually might have been a better way to do it. So then are there any doubles in here? No. So go ahead and write that as square root of 10 and write that as 9. Okay, that is it for this lesson.